Hello people, let's have some fun with primes. I hope you can hear me okay. I'm in the middle of I'm in a truck stop in the town called Gary, Indiana, and I got my windows rolled up and it's hot in here because I just got done driving. Let's say I have a number. I'm going to create a variable called n. So dimension as integer n stands for a number that we're going to test if it's prime or not, or composite. Okay, and let's set the value of n equals 11. Now and we have to create a function. We'll call that function prime test. If prime test n equals true, it's going to either be true or false. Then print prime, else print composite. Okie dokie. So let's come back up here and create that function called prime test. Function prime test by value n as integer as boolean. Let's see. For d as integer equals 3 to the square root of n. If n, the numerator, divided by the denominator, is equal to the integer of n over d, then return true. And if it completes all the way up to the square root of n, and it's still, as soon as it finds that there is something that evenly divides it, it will automatically kick out of this for next and the function and return true. If it completes that for next, it will return false. Okay, and let's put a sleep down here at the bottom. Finish spelling that word correctly. Sleep. And save and run. And here is the result. It says it's composite. Where did I go wrong? Okay. For d as integer equals 3 to the square root of n. Oh, return false. Return true. Okay. Save and run. And it says prime right there. Okie dokie. Let's try another number. Let's try 114343. 114343. Save and run. And it says, hey, I picked another prime number. Let's primes are supposed to be rare. That was just off the hook, right? So let's try a different number. 2 less than that. So let's run this. And effect 114341 is composite. So here we have a function that will do a primality test. It's called trial division from 3 to the square root of n. Now let's look at the time that it does this. So I'll print the time, and then after it gets done doing that, print time. See how long it takes to do that test. It says it's composite, and it does it so fast the time is the same. So let me go back to what we have, 3 right here to begin with. Save and run. Oh man, it's going too fast for us to be able to tell. I don't know what the limit on integers are. Let's try another decimal digit. And still the time frame is still the same. Let's try one more decimal digit. Still the time is still the same. That's a prime. Let's try one more decimal digit. I don't know what the limitation on integers are at. And it says composite. I know I'm getting close to the limit on integers, so dimension as double. Another digit. It finds it so fast. My computer is too fast. One more digit. One more digit. So hot in here. One more digit. And let's make it a 7. Okay, save, run. And it says it's prime. Man, how many decimal digits do we have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11, 12, 13. Let's try a 14th digit. And finally a 15th digit. And it's thinking about it. Thinking about it. Finally, we got 1 second difference. That's let's try one more digit. I think we got to open up the console. Now we're finally getting somewhere with how many digits? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 digits. Okie dokie. So let me help it bring up the console screen. Let's have it bring up the console screen first. pressing A key. Key to begin. And save and run. Okay, so there's the console window. Pressing a key to begin. I'm going to press a key. Here we go. It prints the time. It's running through the 4 next loop, and it's done. So it took from 1804 and 5 seconds to 1804 and 10 seconds. So it took a total of 5 seconds to run. So the reason why I was showing that to you is because this 4 next loop right here is not optimized as, now this is a very basic trial division algo, but it is not optimized in least bit, because I'm iterating the value of D from 3 to 4 to 5 to 6 to 7. So we don't need to iterate every single integer, but we can do a step 2. Now let's save and run. It says press any key to begin. I'm going to press spacebar. 4 is when it started, and 07. So there you go. If before it was 5 seconds, now it's only 3 seconds. And the primary reason why is because we're iterating the value of D from 3 to the square root of n in step 2. So it goes, the value of D is 3, then 5, and 7, and 9, and 11, and so forth. So it did it a little bit faster because it didn't have to iterate do so many iterations. Okay.